chapter number 11, Human Eye and the Colorful World. Till now we have discussed about what is human eye, how it functions. After that we have discussed about defects of human eye. After that we discussed about how refraction is done by glass prism. After that we have discussed about how dispersion of light and recombination of light is done. In our previous video we have discussed about formation of rainbow, how rainbow is formed. Also we have discussed about sunrise and sunset, advanced sunrise and delayed sunset, right? All that things we have discussed. Also we have discussed about twinkling of star, right? So in our previous videos we have discussed all these things. Now today we are going to have the last video session of this chapter number 11, and in this we are going to understand important topic like scattering of light. Also we will discuss in that what is called Tyndall effect, why sky is blue, why space it looks black. Also we can say that why in signals there are always red color, why during sunrise and sunset the color of sun is bit yellowish, right, or bit reddish. So that all questions we are going to unlock here. So let's start our journey from scattering of light. So what is called scattering of light? We know in reflection of light, after reflecting it will go in a particular direction. But in scattering of light, light will reflect in all direction. Means when light is incident on any of particle, right, and it get reflect in all direction, that's called scattering of light. And due to this scattering of light only, this path of light it will get visible. Okay, so it's a phenomena in which path of light will get visible. So scattering of light means reflection of light in all direction. When light is incident on any of particle, it will get reflect in all direction. Now one question will be there in your mind, that sir, every particle do this type of reflection? No, not every particle will do this type of reflection. I think you have studied this in standard 9, that if we have a true solution in a beaker A, suppose here I am having a true solution. And from one side, if I incident the light, so there will be no scattering effect here. But if I have colloidal solution, a colloid solution, so in this case, scattering of light will take place. So scattering of light is done due to colloidal particles. Now what is called colloidal particles? In detail we can say that whose dimension is between 1 nanometer to 1000 nanometer or less than that. So that is considered as the colloidal particles. Now this scattering of light, it is dependent on size of particle and also on wavelength of light. It is dependent on size of particle and also on wavelength of light. We can say that the small size or minute particles, it will scatter the less wavelength, like blue color more, and the large particles, the large size particles, which is also called macro particles, they will scatter the light of more wavelength, like red. Okay, so the small particles it will scatter less wavelength which is of blue color, and the large size means the macromolecules, they will scatter the long wavelength containing light, that's of red color. So in scattering of light, what we can say, it's a reflection of light in all direction by the particles. It is dependent on size of particles and on wavelength of light. Small particle means minute particle, it will scatter the less wavelength containing light, means blue light, and the large size particle or the macromolecules, they will scatter more wavelength containing light, means the red color light. And if the particle is too much large, so for too large particle, it can also scatter white light. For your information, that the blue light, it will scatter 10 times more in comparison to red light. Okay, so this is the concept of scattering of light. Now let's discuss some of the phenomena which happens in this universe by scattering of light. Okay, so let's discuss on Tyndall's effect. As we have seen that when we pass a light from the true solution, it will not scatter and the path of light will not get visible. But when light passes from the colloidal solution, its path will get visible, and this phenomena is called Tyndall's effect. Okay, so from the true solution, no scattering of light, so no path visible of light. But when it passes from colloidal solution, that is scattering of light and path of light gets visible. So this phenomena is called Tyndall's effect. We have seen the common example of this Tyndall effect, the light which is entering from canopy, right? The light which enters into a dusty room. Okay, we have seen there. So first of all, how it happens. So we all know that our atmosphere is a heterogeneous mixture of smoke, different water droplets, tiny particles, and also some suspended particles, etc. Okay, so it's a heterogeneous mixture. Also we can call it that it's a medium of collides. So when light enters into this atmosphere, it will get scattered and different phenomena will happen. But for Tyndall effect, this we will understand here in next two questions. But here the Tyndall effect, you have observed many times that if you are in a room and in that room there will be dust, right, dust particles, and light, a beam of light, it enters into the room, so you can see the visible path of that light. Due to that particles, you can see the visible path, because each particle, it is going to do scattering of light, and due to that the path of the light is getting visible. So that is the example of Tyndall effect. Also we can say that from canopy, if forest, from there also when the light beams enter in from the canopy of forest, so in that case also the path of light, it is getting visible. So that's also Tyndall's effect. Okay, atmosphere, how? Due to the medium of atmosphere, which works as a heterogeneous, and it's also one type of colloidal medium, and which type of phenomena happens, let's see. As As we have seen in Tyndall effect, the path of light will get visible. Right? Now, due to our atmosphere, some of the phenomena happens like why sky is blue. Okay, so why sky is blue? So we know that in our atmosphere, there are many minute particles, and it's a heterogeneous mixture of smoke, water droplets, tiny particles, suspended particles and all. So when light enters into our atmosphere, due to that very minute particle, as we discussed that the minute particle, it will scatter the less wavelength containing blue color more. So when light enters into atmosphere of Earth, so due to minute particles, its blue color, it will scatter everywhere, right? It will scatter in all directions. So due to that, the color of the sky we are having blue. So this question can be asked to you as a scientific reason that why sky is blue in color. So how we can write the answer? When sunlight enters into atmosphere of Earth, right? In atmosphere of Earth there are very minute particles. As the light is incident on that minute particles, they will do scattering of light. As the minute particles will scatter less wavelength containing light, so they will scatter blue color in every direction. That's why the color of sky is blue. So due to minute particles which is present in our atmosphere, the color of our sky is blue. So this reason can be asked to you. The another reason, many times you have seen that if there is a picture of universe, if there is a picture of our solar system, so in vacuum, right, means outside of our atmosphere, outside the atmosphere of Earth, you are looking always black color. So why it is like that? So that can be also asked to you that why color of space is black. Actually, it don't have any color, but we know that in space, in vacuum, there is absence of particles, there is absence of atmosphere. So as there is no particles, so there will be no scattering, and if there is no scattering, so there will be no any color, right? So due to that, due to the absence of that color, it is looking black. Okay, so that also can be asked you as a scientific reason. So now you got the concept that why sky is blue and why the color of our universe, that is black. Also you can understand like in signals why we are using red color. So this is also the important one. In signals, why we are using red color. So what happens? See, as we studied that red color wavelength means it will be scattered by the large particles. Okay, it will scatter by large particles. As we know that if the signal is of red color, so it will be scattered by large particles, and the portion of large particle is less in our atmosphere. So that red color can be stay there for a long time in comparison to any other colors, right? That's why in signals we are having red color. Repeating again beta, the red color, it is scattered by the large particles. The portion of large particles is less in our atmosphere. So as it is less, so it will scatter less, right? And as it scatter less, so for a long time, the color, the red color will be present at the, now just you think that instead of red color, if we will use blue color, so what will happen? As that signal will be spread, minute particles are there, so it will scatter it very rapidly. So blue color will be there, but that blue color can't stay there for a long time. It will scatter, right? So it will be visible for a short time. That's why we are using red color, right? So in signals, red color is there. Same, this is the reason of the school bus why they are in yellow color, right? So which scatter very easily, they can stay for a short time, and the color whose scattering is tough, right? Red color, it can be there for a long time, so we can use that as a signal, right? Because as we know that if there is fire somewhere, so if we give the signal and if it scatter away, so no one will use to know that there is fire or there is an emergency, right? So for that the signal must be there for a long time. Okay, so that is the fundamental concept of that. Why in signals we are using red color. Okay, so hope you understood this, that why sky is blue in color, why color of space is considered as black, and why in signal we are using red color, why school buses are of yellow color, right? Because we know sometimes there is a smoke, right? So in that cases this concept of scattering, it's very important to understand that how the color which is decided, right? How we can decide different colors for signals, for buses and for other purpose also. And this is only the reason that you know that in signal light there is a red color, right? Because it will also scatter less, so the person who is very far away, he can also see the red color, right? All the other colors. In signals we are not using blue color. Why? Because it will scatter very well, right? It will scatter very rapidly, so it will be not useful for the person who is very far away. So let's move towards our next concept, that color of sun at the time of sunrise and sunset. We all have observed color of sun at sunrise and sunset. It is little bit reddish. So why it is red in color? Let's understand. First of all, it must be clear in our mind that red color, it is seen by scattering is done by large particles, right? By macromolecules. So now let's try to understand that what happens. The sunrise and sunset, we know that both of the phenomena, it's happening near the horizon. So suppose here we can understand that this is the horizon, right? Now what happens during sunrise or during sunset? Near the horizon, we know that this is our earth, and the atmosphere near the earth, this will be denser and this will be rarer. So light from sun during sunrise or sunset, it will try to enter into observer's eye. So when it is entering into observer's eye, here you can see that there is a rarer medium, right? So here due to this rarer medium, both of the light is there, right? So from the white light of sun, we know that here it's a rarer medium which will have minute particles more. So here scattering of blue color will be done well. Now when it enters into the denser medium, right, here you can see that from that light, blue color will be almost scattered in rarer medium, but when it enters into denser medium, so it is almost scattered, and here it will be a long route for the light, and in observer eye there will be a wavelength of long light, right? There will be a light of long wavelength, and that is red in color. Okay, so that's why during sunrise and sunset we are having a reddish color of sun. Repeating again, the light which is into rarer medium to denser medium, again, so in this rarer medium what will happen? The scattering of blue color will be almost done, and the light which enters into observer's eye, in that the blue color is scattered, but only the color of long wavelength will get in observer's eye, and that is of red color. Okay, so that's why during sunrise and sunset we are having red color of sun. Again, don't get confused. Blue color is scattered by the minute particles, means by very small particles, and red color is scattered by the large particles. Here it is rarer medium, so it will be of very minute particles, and the density will be less there. In denser medium, its density will be more. So light is entering in this way. So here the scattering of blue color, it will be done, but when it enters into observer's eye, scattering of blue color is almost done by the minute particles, but the light which enters into observer eye, that is the light which is not scattered, and that will be of long wavelength, and that long wavelength containing color, that we know it is red. So during sunrise and sunset, the color of sun is red, right? So it's simple that near the horizon, blue color is almost scattered red color, it will enter into observer's eye, because when light is passing into the denser medium, it will take a long time, right? And as we know that the minute particles are less in atmosphere, right? So it will take a long time. So due to that, the observer will see only the long wavelength containing light, which is red. So during sunrise and sunset, it looks red in color, right? So this can be also asked to you as a scientific reason that why color of sun at sunrise and sunset it is red. So we can give the answer that the light which enters into observer eye during sunrise and sunset, from that the blue color is scattered easily, and the observer will have only the wavelength of only the light of long wavelength, which is of red color, right? So this question can be also asked to you. So this way, in this chapter and in scattering of light, we have understood about Tyndall effect, why the sky is blue, why the color of the universe means a space, it is black, why in signals we are using red color, also why the sun during sunrise and sunset it looks red, that is also explained. More detail is given to you in the worksheet in a very simple language. You can understand from your worksheet. So just complete your worksheet with full concentration, as I have given you the technique how to complete your worksheet, right? So in that way, if you will do, we will first see any of one topic from the video, then complete it from the worksheet and just write it by your own in your notebook. So this way, if you will complete the whole of the session, so I am definitely sure that you will be able to understand all of the concept, even for any of subject it is, right? So that will be our method. So in this chapter number 11, we have discussed many concepts from this chapter. 3 marks of one question is asked in exam. So according to that, it's very, very, very most important chapter. Hope you have understood and enjoyed the chapter. So complete your worksheet and submit your notes properly on time.